Communication Engineering, GATE 2017 Set 1. In the circuit shown, the voltage Vn of t is described by the following relation. Vn of t is 0 volt when time t is less than 0 and it is 15 volt when time t is greater than or equal to 0, where t is in seconds. The time in seconds at which the current I in the circuit will reach the value of 2 amperes is dash. This is a numerical answer type question, and for a detailed lecture on this concept, please refer the NPTEL video, Module 1, Lecture 17, RC First Order Circuit, Complete Response with Step Inputs, Transient and Natural by Professor Nagendra Krishnapura, Department of Electrical Engineering, IIT Madras. In order to solve this problem, we need to know the relation of the transient current of an inductor. This is equal to the final current plus the transient current. Here IL infinity is the steady state current or the final state current, and IL 0 minus, this is the current that is flowing through an inductor before the switch is through. This can be called as the initial current through the inductor, and tau is the time constant of the network, where time constant is given by the inductance divided by the resistance. Let's make use of this concept to solve this problem. In this problem, it is given that the current I at time t1 is equal to 2 ampere, and we are asked to find out the value of t1. We have a parallel combination of two inductors, 1 Henry and 2 Henry. Let us denote this current to be IA. The current IA splits into two, where I1 of t denotes the part of IA that flows through the 2 Henry inductor. Let us first reduce this network and find out IA of t. So the equivalent network becomes 1 ohm in series with a equivalent inductance. The equivalent inductance is equal to 2 into 1 divided by 2 plus 1, which is 2 by 3 Henry. Therefore, the time constant of this network is equal to equivalent inductance divided by the resistance, which is equal to 2 by 3 divided by 1, 2 by 3 seconds. IA of t is given by IA infinity plus IA 0 minus IA infinity into e to the power minus t divided by tau. Let's first find out the final current and the initial current of IA. At t equal to 0, 0 volt is applied here. Therefore, IA 0 minus is equal to 0 ampere, and when time t is greater than or equal to 0, 15 volt is the voltage that is applied. Therefore, the current IA infinity is equal to 15 volt divided by 1 ohm, 15 ampere. Let's just substitute these values here and then find out IA of t. IA of t is equal to 15 minus 15 e to the power minus the t divided by 2 by 3, which is equal to 15 minus 15 e to the power minus 1.5 t. It is given that the current I of time t1 is equal to 2 ampere. This is the current that passes through the 2 Henry inductor alone. This current is the part of IA of t. Therefore, we can apply current division rule and hence find out the value of t1. Therefore, by current division rule, I of t1, which is equal to 2 ampere, is given by 15 minus 15 e to the power minus 1.5 t1 times 1 Henry divided by 1 plus 2, 3 Henry. This is equal to 5 minus 5 e to the power minus 1.5 t1. Therefore, 5 e to the power minus 1.5 t1 is equal to 5 minus 2, 3 ampere. Therefore, minus 1.5 t1 is equal to the logarithm of 3 divided by 5. Upon solving, we can get the value of the time t1 as 0.34 seconds. So the answer is 0.34 seconds. Thank you.